Trinity Maths, Probability Theory. This is our destination. How do we get there? Close the Excel file. From Trinity Maths, select Probability, open Probability Theory. This is a macros-enabled Excel spreadsheet, and I'm looking for find the probability of taking a red ball, random or user-defined. This screen shows 3 randomly generated diagrams. Each time I press the refresh button, I get different bags of coloured balls. Let's choose this trio of bags. Ask your pupils, from which bag do I have the greatest probability of taking a red ball without looking? How to answer that? Well, the probability is equal to the number of red balls expressed as a fraction of the total number of balls in the bag. For the blue bag, the probability is 5/11. For the black bag, the probability is 4/7. For the green bag, it's 7/11. Evaluating their decimal equivalents enables a final comparison with A, B, and C shown as arrows placed precisely on a number line. Hence, it's the green bag I have the greatest probability of selecting a red ball from without looking. Now, this is all very procedural, developing our pupils' fluency, but how can I introduce an element of reasoning or problem solving into this activity? Let's look at the next screen, which shows the same task, but this time we have user-defined diagrams and probabilities. We observed on the previous screen all 3 probabilities were different in value. Therefore, one fraction appeared somewhere between the other 2, but rarely exactly halfway. I'm going to reveal the fraction and decimal for the blue bag and plot its arrow. And do the same for the green bag, but I'm going to hide the black bag. Let's increase the blue bag so it has 1 red ball and 1 blue ball. And increase the green bag so it has 7 red balls and 3 green balls. Now I'm going to ask my pupils, can you design the contents of the black bag so that its probability of selecting a red ball without looking is exactly halfway between the probabilities of the other 2 bags? To clarify this problem for our pupils, perhaps reveal the arrow for B and then increase it so it's exactly halfway between A and C. We know A points to 0.5 and C points to 0.7. Therefore, B must point to 0.6. Our pupils therefore need to find a fraction equivalent to the decimal 0.6. 3/5 would be a great answer, meaning a bag with 3 red balls and 2 black, making 5 in total. By considering equivalent fractions, I'd hope one pupil would suggest a second possible answer, a bag with 6 red balls and 4 black, making 10 in total. But my preferred answer is 3/5. Why? All 3 fractions are simple and equally spaced, and none of the numbers from 1 to 12 appear more than once in their numerators or denominators. Finally, it may interest you to know there are 9 different similar scenarios, including this one, where 3 simple fractions appear equally spaced and none of the numbers from 1 to 12 appear more than once in their numerators or denominators.